Yellow crazy ants. They escaped from visiting ships, and with no predators to control them, they have now created vast super colonies in the forest. When migrating red crabs march into their territory, the ants attack. The crabs have no defense. Blinded and confused, they're doomed.
Every year, over 100 million red crabs migrate across Christmas Island from land to sea, moving in scarlet waves that create one of the most beautiful spectacles of modern nature. But when an invasive species suddenly attacked, the population declined and was headed for extinction. Yet today, the population has flourished, and the island is once again teeming with life. So how did these endangered crabs go from near extinction to the biggest ecological success of modern discovery? Join us as we explore the story of hope and restoration that shocked the world, the paradise and the siege. Our story of restoration begins with Christmas Island, a region that rises from the Indian Ocean located almost 400 kilometers south of Java.
The savage, rocky shores of Christmas Island, 200 miles south of Java in the Indian Ocean.
And 1,500 kilometers from mainland Australia. The island is covered with a dense rainforest and a central plateau that is cut through by shallow terraces and valleys. But people don't go to Christmas Island for its landforms alone, as its isolation has produced an ecosystem with species found nowhere else on Earth. And among the most iconic sights are the millions of beautiful red crabs that migrate each year.
A few hours from now, on this very shore, 1,000 million lives will be launched.
But something deadly was waiting for them. The danger was invisible at first, but its impact would soon spread across the forest. Long before the invasion, the crabs lived safely on the forest floor, hidden under leaf litter and roots. Despite this, the entire ecosystem revolved around their activities each year. Long before Christmas Island was known to humans, the first red crabs arrived from the surrounding regions as larvae in the ocean currents, from the Indo-Pacific. And the lack of large predators on the island meant they could be the main drivers of the ecosystem. And over tens of thousands of years, this was the driving force behind their evolution. With no competition at their level of the food chain, the ancestors of the millions of crabs we see today gradually shifted from living close to the sea to fully embracing life on land. The gills were adapted to absorb oxygen from humid air as their bodies enlarged and their colors became more vibrant. The vibrant colors evolved due to the lack of need for camouflage from large predators, and slowly but surely, the island became a sanctuary, and the crabs became one of the island's dominant engineers. Thanks to the heavy rains of the wet season between October and December, the red crabs leave the inland burrows to begin a long journey down the coastline. As the rains cool the island and raise humidity, the males lead the march by moving down cliffs and crossing the roads in thick red waves. To protect the crabs and keep the movement going, park rangers close many roads and build crab bridges to allow the migration to continue without disturbance. As the males reach the coast, they dig burrows near the shorelines for the females to occupy, and days later, the females arrive to mate. After this, the males return inland while the females remain in their burrows for 2 weeks to lay their eggs. Each female red crab then lays and incubates over 100,000 eggs each, waiting for the final quarter of the moon when the hatched larvae wouldn't be washed back to shore. When the time comes, millions of females gather at the water's edge, lowering their bodies so the eggs can spill into the surf. Then the eggs hatch immediately and begin several weeks of development in open water before returning to the island as juvenile crabs covering the shores in red. This process repeats itself each year, serving as the key to keeping the forest ecosystem going at all times. But then came the big threat no one expected, a small but invasive species known as the yellow crazy ant. Known for their rapid and erratic movements and methods of attack, the yellow crazy ants are native to many parts of Africa and Asia, and somehow arrived on the island, establishing super colonies on Christmas Island. Many ecologists like Sir David Attenborough believe they came through shipping activities. However, despite having a name that puts a warning sign in the minds of ecologists around the world, their ecological impact shows that these ants are more dangerous than they are called. And worse yet, their method of attack is nothing short of devastating. The acid army. At first glance, the yellow crazy ants don't look terrifying to anyone. After all, they are barely 9 millimeters long and look like typical little insects gathering food for difficult seasons. But don't let their looks fool you. Each of these little creatures is powered by a supercharged nervous system, prompting them to move very fast and attack by spraying formic acid whenever they feel threatened. These armies travel in fast swarms that spill over fallen logs and rocks like a living fluid. Whenever they feel disturbed, they vibrate all at once with whipping antennas. Each super colony contains millions of workers spread across several miles, behaving as one entity until they storm across their next prey. And one of those unfortunate to always stumble on their path is the red crab. When this happens, what comes next is an execution like no other. Thousands of these ants swarm up the legs and under the body, spraying formic acid into the eyes,
squirting acid into the crab's eyes and mouths,
liquefying both organs as the victim staggers blindly.
Drop of formic acid, its own venom, from its acidopore and its abdomen and redistribute it around its antenna and face that have been affected with the imported fire ant venom.
As the blind crab tries to fight off these ants, they slip into the gill chambers and the softest tissues on its face, and with formic acid drowning it from inside, it collapses to the ground, alive but unable to do anything. The crab is overcome by shock and suffocation, and by the time it dies, it is bleached pale with its exoskeleton left scarred and etched. After that, the ants move on, leaving the carcass the same and hollowing out the softer tissues over time. This event happens to hundreds of thousands of crabs each migration season, making the results impossible to ignore. When tourists arrive to see the famous river of red crabs headed towards the sea, they stumble across piles of hollow shells instead. Where ants once formed super colonies, thousands of dead crabs are found with shriveled parts littered everywhere. It gets much worse when the land begins to stink over long stretches of road. Rangers on duty have described how visitors freeze in horror after realizing the dried-up shapes at their feet aren't fallen leaves, but remnants of crabs attacked by ants. The numbers get so high that it takes months to clean up after peak migration, and for this reason, there were early efforts made to fight these ants. Most of them relied on neurotoxic insecticides, and though this method killed a huge chunk of the invasive species, they did nothing to remove the supercolonies. The main cause of this problem was found in the way the ants reproduced, as they increased and recovered too easily to be stopped with traditional methods. Worse yet, the toxins from these chemicals lingered too long in soil and water, killing other insects and animals that were rather helpful to the island's ecosystem. Like that wasn't bad enough, land crabs and other arthropods that were already stressed by the acid attacks by the ants found themselves getting attacked by the same efforts made to protect them. Sadly, thanks to the lack of better tools for studying the island's ecosystem, it took a few years for scientists to figure out that they were doing more harm to the environment by their method of controlling the ant population. This discovery was made when a pattern of worse infestations emerged after chemical treatment several months afterwards. All native species got wiped out and easily replaced by the returning ants, easily making the problems much worse than intended. As the ants continued to spread, they reshaped how the island's natural systems worked. The forests in Christmas Island before the attack had thrived, based on the activities of the red crabs, as they were solely responsible for clearing the ground of leaf litter and seedlings. Their work kept other invasive species from taking over, and their droppings kept nutrients recycled at all times. Now, without them, the forests began to suffer. Leaf litter accumulated in thick mats that choked native plants, and young trees sprouted everywhere, blocking sunlight from reaching the forest floor and allowing invasive species to expand their range. On top of that, it was later discovered by researchers on the island that the ants acted as protectors to the sap-suckling parasites that caused branches to wither under the infestations of mold that wouldn't exist with the red crabs at their normal population. Some native insects went extinct, and things were only getting worse. Researchers across Australia got to work trying to find out the best way of stopping the yellow crazy ants without repeating the same mistakes made in the past. The best solution they came up with was finding a way to target the strongest food source that keeps their population going. It turned out that the ants had a main food source separate from the island's red crabs and native insects. The plan was simple: eliminate that food source so the ant population would naturally decline. But things weren't that simple, and scientists would learn that the hard way. The invisible partnership. It turned out the yellow crazy ants on Christmas Island did not conquer the forests by themselves. Hidden under the stems, branches, and underside of young shoots lived the insects that made the invasion possible, the yellow laxscale. These small, flattened, immobile creatures that looked nothing more than tiny wax bumps on the surface of plants looked like minor additions to the region's food web. Except these parasites were the hidden reason why the Christmas Island red crabs were going into extinction. You see, the laxscales fed on the sap of trees and produced a sugary liquid known as honeydew. To most other living things, this was nothing more than waste, but to the crazy ants, it was liquid gold. Many super colonies of ants lived on streams of honeydew dripping from the infected plants, creating a steady food source that allowed them to thrive outside migration season. So while the laxscale had parasitic relationships with plants, they quickly developed a symbiotic relationship with the ants. How so, you ask? It turned out the ants naturally found themselves swarming against predators that fed on those parasites and also stimulated them to produce more honeydew by tapping and striking their shells. In exchange, like an always-running machine, the scales naturally pumped more sugar into the colony, keeping the millions of ants fueled and aggressive at all times. For this reason, field biologists brought in to verify the truth of this described the trees as hidden ant factories, with each trunk getting coated in restless worker ants scrambling for constant food. Without the laxscales, the ants would have never gotten the strength to form large colonies capable of killing tens of millions of crabs each year. Even with the added testimony of consulting biologists, laboratory experiments were done by teams outside the island to prove the extent of this relationship. The researchers collected ants and laxscale insects and recreated the controlled environments and ecosystems in the laboratories. They did this in different conditions to verify what would happen to the yellow crazy ants if the laxscales weren't there. To their surprise, the results were almost dramatic, as without honeydew, the ants didn't grow as fast as they did on the island. Worker numbers dropped like a plague had hit the population, and the yellow crazy ants were no longer active and aggressive enough to live up to the name. Despite the success, the process of reaching this point was far from easy, as most scientists did when measuring the population on Christmas Island was by measuring the number of ants per square meter. Just like that, the colonies that swarmed every surface were now crawling in reformed patterns made to conserve energy until a better source of food emerged like they did on the island. Things changed all of a sudden when the laxscales were brought back, as the ants rebounded almost immediately, forming frantic trails within days and exploding in populations as if the scientists had flipped a natural switch. Now the results were clear, and they all meant one thing: remove the scales, and the aggressive super colonies would disappear. But yet again, things were much more complicated than expected, as the scales turned out to be active partners in destroying the ecosystems of Christmas Island. By draining sap from the trees, the branches grew weak and unable to grow any further. The scales also pierced leaves and stems with thorny mouthparts that made photosynthesis almost impossible, leaving pale scars and patches that would eventually spread and kill entire parts of the trees. Things get worse when the honeydew coating the vegetation begins to attract fungi and create thick layers of black spots and molds. These molds would spread over the leaves and form a dark film that blocks sunlight entirely. Thanks to this infestation, entire sections of canopy once lush and green would become shadowy and lifeless, while in other places where the fungi weren't present, the vegetation grew so thick that sunlight no longer reached the ground. How did this happen when photosynthesis was almost impossible? Well, it came down to the activities of the red crabs that were under attack. Scientists found out that the Christmas Island red crabs ate the fallen leaves and seeds that came down from the trees, preventing too many nutrients from getting absorbed and new trees from sprouting from fallen seeds. Without the red crabs, the vegetation would grow and flourish too quickly, despite the infestation of lax scales, until the island's forests eventually consumed themselves with too many trees fighting for space and sunlight at the same time. In both scenarios, what started as a seemingly harmless partnership between insects quickly grew into a force capable of destroying the entire forests of Christmas Island. It became clear to everyone that breaking this relationship was the key to restoring the lost ecosystem. The big question, however, was how to pull it off. For almost a decade, the biologists on the island had been relying on spraying several tons of broad toxins, and while this worked for a while, the lax scales bounced back not long after. Using these toxins repeatedly was harmful to other members of the ecosystem, and worse yet, some of these scales were developing immunity to the effects of the chemicals. The solution they needed was a biological control agent that targeted the scales without harming the native species and causing harm to native life forms. Scientists scoured online forums across various research communities and traveled to many places in Southeast Asia, studying similar forests for the natural enemies of the lax scale. From beetles to flies and mites, they sorted through and tested each of them on the isolated populations of scale insects under the same temperatures and weather on Christmas Island. Sadly enough, most of the insects chosen were either useless to the mission or so general that they posed a threat to the island's native species as well. Others were more of an ecological threat upon release, so it wasn't a good idea to bring them anywhere outside their natural habitats. But after months of searching, the big breakthrough came from the humid forests of Malaysia. On the host plants found in this region was a tiny wasp that almost went unnoticed. This insect was a parasite for lax scales and seemed to be built for trouble, as the next few days of research would tell. This insect was the tiny Tachyardioephagus somervillei, which we will simply call the Tachida wasp. It was barely larger than a speck of dust, and it reproduced by laying its eggs inside the scale insects. As the larvae grew from within, they survived by eating the insides of the lax scale until it died. Better yet, the wasp always reproduced this way, which was why they were easily found in forests where lax scales flourished. The early tests showed promise in controlled environments, causing entire populations to plummet within days. But there was a huge problem. Introducing a foreign species to an isolated island posed a very serious risk. As we know, history is full of moments when scientists with good intentions and genuine confidence in biological control introduced a species they believed would save an ecosystem that ended up destroying everything. Take the cane toad disaster from decades earlier as an example, coming from a time when scientists with good intentions tried to bring in an external toad species to fight against the beetles that were destroying sugarcane crops across Queensland, Australia. To solve the problem, 102 toads were brought in and released into the fields. And though the solution seemed simple enough, what scientists failed to realize was that the beetles lived too high up the cane stalks for the toads to reach. Desperate to find what to eat, the toads quickly spread out of the regions they were put on and exploded in population. Thanks to their poisonous skins, All predators that tried to eat them died in the process, almost wiping out entire populations of snakes and crocodiles along the way. Millions of toads surged across northern Australia, poisoning everything that touched them. The same thing happened at that time in Hawaii when rats were tearing through sugarcane fields. One scientist suggested importing the small Indian mongoose, an agile predator that was used to hunt rats and drive them out. Again, the suggested solution made sense on the surface, but the problems didn't come up until the mongoose arrived. It turned out the rats were nocturnal and the mongooses diurnal, meaning they rarely met at all. Now, free from restraint, these mongooses devoured native wildlife instead, raiding nests, eating the ground-dwelling birds, and wiping off many species that grew without predators. Their attempt to save the ecosystem only ended with wiping off large parts of Hawaii's biodiversity. Still, with so many experiments made not to repeat the same mistakes, the entire Tachita wasp population arrived in Christmas Island in a sealed container packed in vials no larger than a thumb. And then, the unthinkable happened. Releasing the army. Although the initial plan was to drop the large populations of wasps via helicopters, the same way the toxic pesticides were sprayed in previous years, the transport process instead was deeply controlled and carefully monitored to make sure the risks could be mitigated in case things didn't go according to plan. Inside the quarantine facility on Christmas Island, scientists opened the containers one at a time and carefully examined each wasp with magnification and recorded every movement. With reluctant approval from the Australian Department of Agriculture, Forestry and Fisheries, there was a lot of pressure for this to work, because if it didn't, it would mean the end for the entire red crab population. The future of Christmas Island was resting on this being a success, and the wasps were provided clusters of yellow lac scales harvested from the island's forests. Once this happened, their instincts activated, and the female Tachita wasps pierced and injected their eggs into the bodies of the scale insects. As it was in the forests of Malaysia, the eggs hatched and began consuming the scales from the inside. With excitement, the researchers watched as the infected scales slowly changed in color and texture, a sign that the eggs had attached and the larvae were thriving. Over weeks, the wasp's life cycle progressed exactly as it had during the Malaysian trials, with little to no changes that affected the outcomes intended. Among all the native species brought into the laboratories, the target of the wasp was always the lac scale, and no matter what happened, it ignored all non-target insects, even when offered alternatives in controlled tests. This was like a dream come true, and months later, when all the ecological risk assessments had been met and each possible outcome had been studied, the next phase began, releasing the populations into the island to do their thing. To keep things under control in case of trouble, the release happened not across the entire island, but in carefully chosen forest blocks that could be fenced and monitored daily. This way, if everything goes smoothly, the entire population could be released, and if everything goes south, the entire population could be wiped out within the enclosed space. With multiple cameras rolling and multiple specialists watching, thousands of these wasps were released into the undergrowth. They spread out silently, quickly settling onto branches and stems. The males searched far to find food while the females occupied themselves with finding a home for their eggs. The earliest surveys after the release showed slow but promising signs of impact, and that included a slight reduction in honeydew on monitored trees. After that, the experts noticed a thinning of sooty mold on certain leaves, slower and weaker trails of aggressive ants along trunks that had once been major feeding highways. These patterns showed the process was working, and the only problem was that it was slow. This meant Christmas Island would still have to deal with attacks from yellow crazy ants on red crabs for at least a few years before any substantial results would be evident. These wasps, forced into a new environment, needed time to adjust, build their numbers, and take their place in this new world. They also needed time to establish reproductive cycles across different parts of the new area, before spreading outward into new pockets of infestation within the closed space and eventually beyond. Because of how slow the process was, the first year tested the patience of the research teams. Some monitored trees showed improvement, while others seemed unchanged. The ants remained stubbornly abundant, even though early behavior shifts indicated that their food supplies were becoming less predictable. The researchers kept their data collection intact by counting scale infestations, measuring honeydew presence, and tracking ant trail density on trunks, even though the numbers weren't encouraging. Christmas Island relied on the annual migration of red crabs to keep natural research funded and tourism ongoing. And with the numbers continuing to dwindle, there seemed to be no hope on the horizon. All this time, one question lingered in the minds of researchers and long-term tourists. Would the island's ecosystem ever be restored to its former glory? The restoration and the long fight. Despite the endless drawbacks, slowly but surely, things began to change, and new biological trends emerged beneath the surface. Now, scale populations weren't just declining, but entirely collapsing in certain test zones. This was the result the team had been waiting for, and all it took was almost 2 years of backbreaking surveys for the first breakthrough to emerge. Branches that had been coated in sticky honeydew residue began to dry. Leaves once darkened by sheets of black mold were returning to a muted green. Ant numbers followed a slower pattern, but downward nonetheless, showing the same signs of the loss expected after cutting off the main resource that had powered their super colonies for decades. Thankfully, by the second year, the change was impossible to miss. In the monitored plots where thousands of wasps had been released, the scales had been reduced to a fraction of their former numbers. Honeydew. Production fell so sharply that some ant trails disappeared entirely, leaving only scattered foragers instead of the dense armies that once covered the forest floor. Rangers began to notice open patches of leaf litter where ants no longer dominated every inch of ground. Seedlings that had suffocated under mold or weakened by scale infestations pushed out new leaves and grew at healthier rates. They were now excited for the next red crab migration season. Finally, there would be no more roads filled with empty shells and the stench of dead animals. Slowly but surely, the forests were being restored to what had been lost during the height of the ant invasion, as the constant frenzied activity along the trees had almost disappeared entirely. But that was just the beginning, as the most dramatic proof of change appeared during the next wet season. It was 2017 when this happened, and when the first rains hit the plateau, red crabs began their annual migration in numbers larger than any migration seen by tourists since 2008. At first, it seemed like something happening by chance, perhaps from a favorable season caused by unknown factors. But as the flow of crabs stretched from the inland forests toward the coast, scientists realized they were witnessing the ecological ripple effects of the wasp introduction. The crabs had been wiped out in huge portions of the island, where ant supercolonies had flourished, and for years, migration counts had remained at historic lows. But with scale insects collapsing and ant numbers falling, survival improved. Just as researchers hoped, millions of crab juveniles returning from the sea faced fewer deadly ant carpets, fewer acid attacks, and fewer areas where supercolonies had once formed impassable zones to cross. Christmas Island had become a safe haven for the red crabs once again. As the migration numbers increased, roads filled once again with the moving red tide that had long marked the island's natural identity. Rangers found fewer dead crabs along the pathways, fewer piles of bodies dissolved by formic acid, and fewer stretches of forest where the ants still held ground. After the red crabs began returning in larger numbers, their presence gradually rewrote the entire ecosystem. The crabs were now the engineers of the highly reformed ecosystem, constantly turning over the soil and always the forest floor as they moved forward. With each passing season, as more young crabs survived the dangerous journey inland from the sea, Their activities became easier to see within the forests. Areas that had once grown thick with tangled underbrush began to open again as the crabs resumed their favorite activity of eating and cutting down young plants and fallen leaves. This kept the forest floor clear enough for native seedlings to grow at a steady pace without being smothered by mold, leaf buildup, or invasive vines. New trees also didn't grow too often, as they did when the crabs weren't there to keep them in check, and as the population grew healthier, nutrient cycling also improved across the island. Thanks to their constant foraging, organic matter broke down at a rate that the forest had been missing for almost 10 years. Ironically enough, the Techeetah wasp, barely seen by the tourists, was behind this success. It was barely visible to anyone, yet its work had started a process that led to this brilliant outcome. Its impact moved through the ecosystem silently, but one at a time. It slowly restored balance to Christmas Island, clearing the way for the red crabs to return in the numbers the island had nearly forgotten. And even though the yellow crazy ant population cannot be completely eliminated, Christmas Island stands as one of the biggest ecological successes that shocked the entire world, showing everyone that sometimes nature has what it takes to bring healing to a dying ecosystem. So, what do you think? Will Christmas Island continue to flourish as it does today? What other ecological success stories would you like us to explore? Let us know in the comments down below. If you enjoyed the video, please make sure you like, share, and subscribe. Also, click on the next video shown on your screen. You will enjoy it.